Welcome to everyone. Thanks very much indeed for joining us at this ITRC webinar. And the topic of today's webinar is on digital infrastructure, both fixed and mobile communications infrastructure. For those of you who've been with us throughout this webinar series, you'll recognize that we're coming to an end of the series. It's been a fascinating tour, at least I think it has been, reporting on not all, but certainly a big chunk of the work which has gone on within the Infrastructure Transitions Research Consortium over the last 10 years. We began back in September with an overview of the system of systems analysis, which was developed within ITRC. And then after that first overview workshop, where we were joined by the National Infrastructure Commission in this country, we've taken a series of deeper dives into particular aspects of the ITRC's research. Our subnational analysis of the Oxford-Cambridge Arc, our international development work, and then looking at the interdependencies between energy and transport systems, which is one of the most interesting and important interdependencies as we navigate towards a net zero future. We then looked in detail at the ITRC's work on infrastructure network resilience, and in particular responding to climate-related shocks to infrastructure systems. And then most recently, last week, we had a webinar looking at the ITRC's national water supply modeling and some of the interdependencies between water and energy systems. So that then brings us to this week, where we're looking in particular at digital infrastructure, which we've really come to learn a great deal more about during the ITRC's journey. Much of that learning has been thanks to the work of Edward Oughton, who you're going to hear from in a moment. I think we've done some really both important conceptual work and some very practical work to work out how we should think about and analyze digital connectivity on broad scales. And today's webinar is going to be very broad scale because we're going to look at a number of countries around the world, and we're going to look at a number of very different settings for the rapid rollout of digital infrastructure. This was actually to be the last of the webinars in our series, but we've managed to arrange with the NISMOD development team at Daphne, the Data and Analytics Facility for National Infrastructure at the Rutherford Laboratory in Harwell, to do an in-depth session where they will showcase Daphne's capabilities and walk through how NISMOD has been implemented on Daphne, and provide quite a technical look under the bonnet of Daphne. So we don't yet have a link and a registration for that, as far as I'm aware, but we will be publicizing that. And if you want to hear more about NISMOD on Daphne, then please join us in January. The other thing I should say is that all of the past webinars are now available on YouTube. So if you've missed any of those and you want to catch up, then have a look at our website and you'll get the link through to the previous webinars. And today's webinar within a couple of days will be up there on YouTube as well. Please keep on using your social media to publicize this webinar series, and by all means tweet as we go through today's webinar. And as with the previous webinars, we are going to be collecting up questions in the chat and be using those as the basis for our discussion. So please use the chat, use it straight away, and put your questions in there and add those questions in as we go through the presentations, and then we'll be able to pick them up. Both the presenters and the panelists will be able to pick them up as we go into the discussion. So today, to kick us off, we're going to have a presentation from Dr. Edward Oughton, who's been with the ITRC program almost from the outset. He did his PhD in the University of Cambridge on the economics of digital connectivity, and then did a postdoc in Cambridge, and then came to Oxford doing all of the analysis that you're going to see in a moment, which has really gone from strength to strength incredibly well, and as you will see, has acquired remarkable global reach very, very quickly. And then last year, Ed was honored to be offered a position in George Mason University, where he's now moved to in the United States. So in a moment, I'll hand over to Ed, but first let me, so you can see who's coming, briefly refer to our panelists who will be responding to Ed's presentation and making some remarks from their own perspectives straight after that presentation before we go into the discussion. And so it's a great pleasure to welcome a very international series of respondents this afternoon. Julius Kasuma, who's a research scientist at Facebook Connectivity, Bill Lehr, who's a distinguished scientist at the Computer Science and Artificial Intelligence Lab at MIT, and Tania Begazo-Gomez, who is a senior economist for digital development at the World Bank. So an extremely distinguished and very well qualified panel to comment on these issues of analyzing digital systems connectivity. But first, let me hand over to Dr. Edward Oughton for his presentation on the ITRC's work on digital connectivity.
Fantastic, thank you very much, Jim. I hope that you can all see the screen now. So please let me know if not. So it's great to see you all. Thank you for tuning in today. I'm going to give you a very quick research showcase across the projects that we've worked on over the past 5 years. And actually, it all started around 2016 when we kicked off the research. But actually, in about 2015, the government recognised in the UK that actually it was behind where it wanted to be in terms of digital infrastructure availability, in terms of fixed broadband, fibre penetration, but also it was quite slow to roll out 4G, and therefore it wanted to try to improve its level of mobile broadband availability. So it tried to set out a strategy for how it could become a leader in the deployment of 5G early on, to try and correct for where it went more slowly in the previous generation. So essentially, we're looking at these documents here from the NIC, where they were tasked with trying to lay out how a strategy could be developed for the UK to improve its digital connectivity. And really, when you look at this in the global context, there's actually a long way to go for many low and middle income countries too. So we can see in yellow here, we have 4G availability, we have 3G availability in blue, and we have red in 2G. So there are many countries who are actually quite far ahead in terms of their 4G availability, but then you can see quite a lot of red and blue for 2G and 3G respectively across the globe. And really the tools that we've developed were initially piloted in the UK and applied there, but now we've scaled them to apply them to other contexts. And the approach that we've taken is that we want to be able to estimate demand at the local level, and that's meant that we've had to use global data sets and actually rely more on kind of remotely sensing the metrics that we're interested in to try and support that demand estimation process. And then also to basically design least cost networks so that we're able to understand what the cost may be for different technologies. And then the aim has been to be able to then provide decision support results to inform governments or private sector operators on the capacity coverage and the costs of different digital infrastructure strategies, depending on the different fiber or cellular-based technologies that they might use. After completing the UK assessment that we did as one of the first applications of the model, we realized in then applying it to another country that it was actually incredibly laborious and maybe too country specific, some of the data sets that we were using. So since then, our approach has been focused on trying to develop a global model of digital infrastructure assessment so that we can quite easily dip into other countries and apply the model on a more rapid basis. And this is just giving you a flavor of the scope that we have within this ITRC approach. And here we're looking at universal broadband service estimates for rolling out 4G across continental Africa using a wireless backhaul. So this has been a kind of backbone of the work that we've been doing in the last year, trying to go upscale and to go and look at larger geographical areas. In terms of the demand estimation part, we use a set of scenarios. It's a scenario-based approach, for example, for the number of people who may subscribe to mobile, but then also to estimate the number of smartphone users, because ultimately for 4G, for example, the data-intensive users are going to need a smartphone. So really the analysis is dependent on that. So you can see the type of exogenous scenarios that we use on the left-hand side here. But for the actual spatial estimation of where adoption is taking place, we've got quite granular with the way that we do this. So on the right-hand side here, this is an example of where we try to estimate a cell phone adoption at the local level using satellite imagery to see if we could try to push the research forward a bit and try and provide a better estimation at the local level, going beyond the kind of national statistical survey-based approaches, which mainly only give you kind of a single data point for a specific location. So what do we do in terms of the least cost network designs? Well, essentially we developed initially a fiber to the premises design model for the UK. Here is an example of how we applied it to Cambridge to look at premises level fiber optic routing. And actually we were then able to kind of use these network design algorithms that we developed to start to apply them to other countries, so that we could look at the least cost network strategies, for example, for 3G or 4G in many of those countries where digital connectivity is still lagging. So for example, here we've been looking at the required fiber to connect different locations across Uganda, Malawi, Senegal, Kenya, Pakistan, Albania, Peru, and Mexico as part of the World Bank work that we've been doing. And really now we've got this nice modeling capability that allows us to use the data that we have available to try to understand what the costs may be for connecting different people in different locations. And the analytics that we produce in this essentially include the total cost for different strategies. So for example, if we look at the cost on the left-hand side here, this is the cost for universal service across 6 different African countries. And essentially we're looking at delivering 4G using a fiber backhaul or a wireless backhaul, and then comparing those costs with using 3G, for example. And it's important to have the aggregate costs, but we're also able to show the cost composition, which is really important, because ultimately this modeling framework that we've produced allows you to ask what if questions. And there are lots of levers that government have available to them that can change the cost composition. So the network is a portion of the cost here. We can see the radio access network, the backhaul, the civil engineering costs, etc. But then we also have the spectrum and the tax burden that may be placed on an operator. And they are levers that can be changed in order to encourage the rollout of universal broadband. So that's kind of a high-level overview of the capability that we've developed. Now I'm going to give you a little bit of a research showcase around the projects. So in 2016, we started out working on this UK assessment of 5G deployment, which I did with my collaborator, Zoraida Frias, who's at the Technical University in Madrid. And we developed this initial model to look at the capacity, coverage and cost of 5G strategies in the UK. And we also looked at transport infrastructure. And that was kind of an important stepping stone for us to actually develop the analytics that fed into the more sophisticated work that we did later in the project. It was a good experience to go through, as we were able to use the analytics to kind of drive some of those key findings that went into the UK strategy. And once we completed that, the same research team was also then asked to apply the model to the Netherlands, which was a useful process to go through. And one of the important parts of doing that was to start to think about what the cost may be per user, which was different to how we thought of it before. And that's now a key part of our analysis. We were very lucky to get money from the Digital Catapult as part of this exercise, essentially to develop an open source 5G assessment model, which was able to couple together the engineering part of cellular, so the infrastructure part, with essentially the cost component. And this was a piece of analysis that we did and we published it in IEEE Access, forms part of the key simulation model that we use to do the capacity planning across the wider modeling platform now. But this was a very useful exercise to go through, especially to collaborate with those at the Digital Catapult. More recently, we've been working on a Python version of the classic Longley-Rice model, which is a classic propagation model, which was developed in the 60s out in Colorado. And the code at the time that was released was still, in many cases, in the original Fortran 88 from the last iteration, which was a couple of decades ago. And actually, we took that, so it was a research collaboration with Facebook Connectivity and Ohio State, and we produced an open source Python version of this, which we published, so that researchers who may want to use this, given that it's a standard model which is used throughout the industry, would have a version available to them that they could rely on and trust because it had been fully tested. More recently, we've been working on the 5G flagship for the World Bank. So there's a lot of hype around 5G, and there's definitely a lot of hype around the applicability of these technologies for low and middle income countries. There's very little transparent, reproducible evidence which is actually able to kind of capture the key engineering dimensions with the actual costs of investment. And the costs of investment are significant for some low and middle income countries. So what we've been trying to do here is to produce this analytical framework which we can apply to low and middle income countries to estimate the costs globally. And we've now finished this piece of work, and the paper is actually ready to be submitted. So you'll see this surfacing as a working paper very soon. And then finally, just to finish off, there's another piece of work that we've been doing with the World Bank on the Digital Economy for Africa program. Again, applying this modeling platform that we've developed, but this time to look at those countries that are maybe thinking about moving to 3G from 2G, and whether they should do that or whether they should leapfrog forward to just deploying 4G. And this is the work that currently I've been doing with Tania Begazo from the World Bank, and which will also be surfacing in the next few months as we finish this working paper. So that's a research showcase of the approach that we've taken in the ITRC, and then also an overview of the different projects, some of the highlights that we've had in terms of how we've been able to develop these models and tools, essentially, that have been funded by EPSRC. So with that, I'll thank you all, and I'll pass back to Jim.
Thanks very much indeed, Ed, for that high-speed but very interesting and extremely impressive tour through what you have developed, starting in the UK and then rolling out all over the world. I'm now going to hand over and introduce three people who are going to respond to that and provide some personal perspectives. Before I do, let me remind you to put your questions in the chat function. Any questions, both technical, regulatory, economic, political. We've got a a whole bunch of very experienced people on the webinar this afternoon. So please go ahead with the questions. But before we start the discussion, let me first hand over to Julius Kasuma from Facebook Connectivity. Great pleasure to have you with us, Julius, and to hear your take on the issues we're grappling with this afternoon.
Thank you, Jim, and thank you, Ed. Good morning, good afternoon, and good evening to everybody who's attending here today. Connectivity is really important, and it's really difficult to understand. The problem is really complex because the world is diverse, and we, the people, are also very diverse in our connectivity needs, connectivity aspirations, and connectivity potential. That makes it really, really difficult to be able to find solutions that are timely, sustainable, and scalable. Speaking of timely, who would have thought just months ago that I would be arguing with my son in kindergarten about upload speeds? It's really amazing how the changes in the world today has led to vast increases in data usage and connectivity use. Unfortunately, many people around the world are still underconnected. They're underconnected, uncovered for many reasons: availability, lack of affordability, and lack of relevance. In particular, being able to address the rural side of our planet is really, really challenging because of lack of development. How do we begin to solve this? We need the right sets of complete solutions. We need solution elements that range from the fundamental to the applied to the specialized. And we need to find a way to be able to harmonize them. This is why I think the work that Ed has been leading is really, really important, because we have to know whether technology transfers are possible, new solutions are timely and useful, and to what extent are they going to be relevant. We need to be able to harmonize our thinking to be able to benefit from scale on one hand and specialization from the other one. Speaking of rural connectivity, one pain point that I've been looking at, is the lack of backhaul. Backhaul is the link of the network that connects the core network into the edge. Fiber or microwave, wireless, or satellite. Wireless backhaul is really, really important in rural connectivity because it provides a very timely, cost-effective solution in many cases. However, like Ed mentioned, the propagation models that people use today to design such links, there was significant work in the 60s, but we lack the new development to be able to specialize these to difficult terrain, to difficult foliage conditions, and to the broader parts of the world that lack connectivity. In the age of big data, surprisingly, there's lack of systematic data. And this is one of the things that I've been addressing with the help of Ed and many other universities to be able to design networks reliably and cheaply and effectively. Also, in addition to that, not only is the terrain challenging, the lack of infrastructure is really challenging. And this touches a lot of the other work that the ITRC has been working on, such as on power, materials, and water. It's really amazing to see how much people in these rural areas are willing to work to get the connectivity that they want and they need. When there's no water available, they will dig pits and catch rainwater to be able to build the foundation for the telco towers that they need to gain connectivity from. And with that, thank you again for inviting me to participate in this panel. And I will hand over to my other panelists, Bill and Tania. Thank you.
Real pleasure, and thanks to Ed and Jim both for inviting me to participate in this. So I was asked to talk about, what is the relevance to this stuff in the high-income countries like the US and Europe, and you've already seen some examples of this in the models that Ed's done. Increasingly, we obviously live in a more connected world where the local and global decisions we're making have spillovers in many more complex ways, and that's largely a result of ICT capabilities. And all of the earlier seminars that talked about other infrastructures, a lot of the advances in those will depend on the sort of ICT infrastructure we build out. A significant component of that is I would call next generation wireless, which a lot of people refer to as 5G, but 5G often gets confused with what the mobile network operators call it. And that's okay if you take that definition, but the future of the wireless future we're going to build is going to involve a lot more than what the mobile network operators think, and it's going to involve a lot of other wireless technologies. One of the key challenges we face is building out the small cell infrastructures. And by that, we mean smaller cells from the base station, which means more of the wired infrastructure going closer to the edge so that you can do all the kinds of things that the 5G networks promise to do, which is an order of magnitude improvement in every possible performance direction. Now you can ask yourself, do we need all of that? And part of the value of these models is for us to examine how much do we need. So like how important is low latency? What speeds do you need? Where do you need those speeds? How many devices am I going to get connected? Is it going to be thousands of devices in a particular area, or is it going to be hundreds or a few? And how fast are you going to realize those worlds? All of those sorts of things are the kind of questions that you need if you're going to attempt to evaluate what is the right technology solution to answer local needs. And you have to recognize that when you build out this small cell infrastructure, you're going to involve many stakeholders. You're going to involve, obviously, the consumers are going to be using this and buying the broadband services. All of the businesses, the smart X businesses that are going to be taking advantage of the technology to do things in new ways that the digital capabilities enable them to. The network operators, which certainly includes the mobile network operators, but also the fixed ones and new kinds of operators, and the government. And they're going to be doing this at multiple scales. It's going to be local, regional, and national investments are going to need to get coordinated over multiple planning and investment horizons. Most of the investment is going to be private, but there's going to need to be public investment also. And you're going to have a mix of long-lived and subject to rapid economic depreciation assets. A lot of the passive assets, the things like conduit and fiber in the ground and towers and all that sort of stuff, is going to move more like real estate and subject to things like rights of way and zoning regulations, which often has a very strong local component. The digital active assets are going to be, subject for things like technology regulation, but all the other domains. And a lot of the assets are also going to need to be shared. So to figure out how you're going to do this, you're going to need the capability to do the engineering cost modeling alternatives, the demand forecasts, the trade-offs of social and private returns on investment, pricing and competition, affordability implications, all this sort of stuff that the models that Ed was talking about would give you a help to address. So if you think about like breaking it down into what are some of the kinds of questions you have to ask, well, if you're talking about the technical architectures of 5G, and that's very much unsettled at this point, you have to figure out how do you divide where I locate active networking type of functionality closer to the edge or in the core or the cloud, and how do I share that with passive? So things like sites, rights of way, structures, that sort of thing. 5G types of technologies as defined by the mobile network industry is clearly part of it, but also things like Wi-Fi and lots of other technologies like LEO satellites, millimeter wave technologies. Some of these things are still coming off of coming out of R&D. They need to figure that out. And if we build out the mobile edge computing to enable things like real-time control, the architectures for that are going to take a lot of analysis, and how fast do we need to, all that sort of stuff. From a business model perspective, we've got the issues with, what is the level of convergence between mobile network operators and also fixed broadband? And what about new types of edge providers like neutral hosts that would provide infrastructure that was locally owned or owned by local people that would connect into and be shared by wider area network providers. And then also a lot of opportunities for end user networks. One of my interests is in the possibility of enabling more of that sort of stuff. There's going to be a lot of concerns about things like smart city investment. From a regulatory perspective, all of the standard regulatory policy domain issues are going to need to have common bases of talking about their problems. First, universal service obligations. What broadband do we want to guarantee to consumers? And what do we consider as underserved communities, and what sort of subsidy needs are there? Most of the infrastructure provision in the advanced economies is going to be by competitive markets, so we're going to want to try and deal with that. And then I've mentioned already the need to share the framework. So can we come up with good models for how to share both the passive infrastructures and, to the extent we want to share, in the active networks? And then spectrum management is a whole nother issue that I'm not going to get into. The future of this, the planning future here, is to build a smart X future of real and virtual world convergence. That is a path that we are heading towards as we head towards this digital future. So when we think about how we're going to integrate automation into our society, these are issues that are going to cross over every possible policy domain. And so understanding what's happening at the infrastructure level of the ICT is going to be really important to be able to engage the policymakers in the considerations in everything from fintech to smart healthcare to green energy. All of those policy areas are going to depend heavily on what happens and the kinds of models I believe that Ed and Jim have been working on. So with that, let me stop and pass it on to the next.
That's fantastic, Bill. You've covered a whole load of ground, which has raised a lot of questions which I would like to ask you, because these are really current issues. But I'll hold back for the time being and invite more questions in the chat, please. And before we embark upon the discussion, a great pleasure now to hand over to Tania Begazo from the World Bank, who's been supporting Ed's work, and really very keen to hear your perspective in terms of digital provision in low and middle income countries, Tania.
Thank you. Good morning, everybody. Good afternoon and good evening. Well, in the case of the World Bank, we have been very lucky to work with Ed in two projects, one on universal broadband in Africa, and the other one, the 5G connectivity in developing economies. For us, the key objective was to try to find a way of show how to minimize the cost of infrastructure deployment, given the available technologies that we know right now, and also understanding what would be the least costly policy option to reach universal access from the government perspective, especially in this context where you have very low demand per consumer. So for us, the challenge was data on demand, on supply, and even on policy parameters. So actually, we really like the model, the ITRC model, because it uses other sources of information that can help us bridge this gap and actually even encourage then the governments or the companies to provide additional information to just refine the findings. So as you know, in the context of developing economies is different. The reality is different. For instance, in sub-Saharan Africa, already on 45% of the subscriptions as 2G still compared to 14 in Europe, and 4G is only 10% compared to 58 or almost 60% in Europe. So we have all these different barriers that were mentioned also by Julius that are like going beyond the existence of infrastructure. So we have a very large also usage gap of around 49% in the case of Africa, where there is a network but it's not used. So we are thinking also of what other complementary policies can be used. I mean, one is on the side of promoting competition and making sure that everything is like the devices and also the data is more affordable, but also thinking of what is the role of government providing subsidies and where it is better to do it on the demand side and also on the supply side. So for instance, in the case of Africa, mentioning the issue of lack of data, only 19 out of the 48 countries have a household survey that has been done in the last 10 years that include a module on ICT, because there are others that even ICT is not included, or it focuses on just telephone. And we don't even have like information on expenditure of telephone access, etc. So using these alternative models with satellites and others have been very useful for that. Also, detailed information of the network layout in different countries is not available, not even for regulators in many cases. Even GSMA has managed to collect this information for some few countries. Now they are expanding. So the use of this alternative data and being able to convert information on coverage into the actual location of the infrastructure has been very useful, and it has been an additional contribution from the project. So how have we used these kind of models? So in both cases, the results and the insights from the models are feeding into regional and global flagship reports, where we are trying to show the government's alternative paths to increase broadband penetration and also make them think of the policy options that they can take in order to make this a reality. So for instance, regulating better spectrum or taxation or infrastructure sharing or providing subsidies. And for us, it has been useful to highlight what is the limit of commercial viability and also what is the limit of just regulatory reforms to understand where there is need to also complement with additional public investments. We are using the results as an advocacy tool for reform, as I mentioned, with some countries interested in deploying public infrastructure or supporting the sector as well. And only in the last month, after doing the work for Africa and for the 5G, we have received requests to conduct similar analysis for 15 additional countries, including countries in fragile or conflict-affected situations that are assessing reconstruction efforts. What would it take to reconstruct infrastructure? Other countries that are planning to launch 5G auctions and also need a more detailed understanding of what are the options. On countries that also want to promote infrastructure sharing across sectors, for instance, in the case of electricity as well. So this highlights actually the versatility of the model that can be used for all these different policy questions, different contexts as well. So just to give you an example of few examples of the benefits of this, the insights. So for instance, we find that the 4G with a wireless backhaul is like the most cost-effective alternative in many countries in sub-Saharan Africa. But then once you go and see, the government hasn't even released or assigned the spectrum that would allow this to happen. Or there are issues with how the microwave links are assigned, or the fees that the companies have to pay for that are very, very high in some countries. So this kind of opens the door to talk about specific and more detailed issues in some of these countries. So in the case of 5G, there was there are a lot of skepticism about the viability in developing economies, but actually the findings show that in certain countries under certain parameters, that can be viable, especially considering non-standalone solutions. So this is, I think, important to have a basis to complement also with other kind of questions or models of thinking that can help us to think also about competition and how to ensure competition and complement the findings of these models, and also understand also the specifics of the country regarding also the political economy of how these developments plan to happen. So I think it has been very, very useful so far, and we are expecting to continue working with that on this and the team. Thank you.
Great, thanks very much indeed, Tania, for those remarks and insights regarding the situation in low and middle income countries around the world. We're now going to enter the discussion.
So I think just starting from the questions, I have one from Dr. Hassan Osman at Real Wireless, and he asked this really interesting question: is the work completed? And it reminded me of that classic academic comment, which is, what is finished? I mean, you run out of funding or you run out of time. So definitely one of those things has happened. We published quite a bit of the work, and actually it's available on our GitHub profile. I would say that the work for the whole integrated assessment platform is actually really part of the World Bank work that we're now putting out as a working paper. So really that's the project that you need to look at for the code. So it's the Python Telecommunications Assessment Library. The code there is, I would say, about 90% finished. But as we basically move towards submitting those papers over the next couple of weeks, that will move towards being pretty much fully completed. And then we definitely like you all to use the code. We put it out open source. So we hope that you can actually access it and use it, and we can put this all to good use. So I think that yeah, we very much encourage you to try and access the open source code, or to reach out to us and engage around how it could be applied in different situations. So that was the first question. I noticed that we had a variety of other questions, and I'm going to come back to some of them, but I noticed that there was one here which I think would be very good for Julius. The question was from Luis Mendo, and Luis has asked, how useful is it to have a Longley Rice implementation compared to other modern and possibly more accurate models? Is the Longley Rice model more robust against terrain height data inaccuracy, for instance? So Julius, if you want to pick up, I'm sure you have something to say about.
And thank you for the very good question. So when we speak about connectivity, like Bill and Tania already hinted, there's a wide variety of use cases. And one of the things that drives the use cases are going to be what kind of data is available and what kind of performance is to be expected. Longley Rice has proven to be to have a lot of longevity because Anita Longley did amazing work when she was alive, and I think for rural areas it holds a lot of promise. We've done some comparisons between Longley Rice and more sophisticated ray tracing and physics-based models. And depending on the situation, Longley Rice is still very competitive. And it is the model that is used in, I would say, almost every single microwave backhaul link design in the world today under different names. So I think it's good to invest in that. Speaking of that, I just want to add also something that Bill hinted at, which is that when we go from 4G to 5G, 5G brings a lot more flexibility in architecture decomposition, and that will give a lot more flexibility in how big the sites are in terms of physical size and coverage and data and capacity. And I think we will need not just one propagation model to solve all the different deployment scenarios. Thank you.
Thank you very much, Julius. So just picking up on some of the other questions, I noticed we had a couple, so one from Camilo and one from Calvin as well, talking about the image recognition work that we did and basically asking, what exactly are you picking up there? What I should say is that we basically compared the effectiveness of that approach against just scaling adoption against population density or nightlight luminosity. And actually, we found that the kind of more fancy, more time-consuming machine learning approach was about twice as accurate at estimating the amount of broadband penetration or cell phone adoption, for example, at the local level. And at least for the countries that we applied it to, so Malawi and Ethiopia, the main differences are that the shape of the buildings, the building material, for example, and we were able to work this out by doing back propagation on the model, essentially. So low income houses might be round and made of organic materials, whereas higher income houses might be square or rectangular shaped and have more of a structural roof, which consists of tiles or corrugated iron, and there might be other types of infrastructure in the site, like roads, for example, which are more noticeable. And this is the type of thing that, using a convolutional neural network approach, you're able to try and pick up and provide more of a nuanced understanding at the local level. And we think that this has kind of pushed forward our demand estimation work. I would say it's still work in progress, and I know that, Calvin, you're working on similar things as well. There are issues with it, but I think that it's definitely been kind of demonstrated now to be something that is of use to us. It's of use to your GSMA members, I think, as well, potentially for greenfield areas. So I hope that this moves forward in some sort of useful analytical way to actually support real-world decision-making. Okay, so let me have a look at the other questions here. We have a question regarding low Earth orbit satellite constellations, and it's come from Bonfo Cesaro, and the question there is it possible to shift to new LEO constellations such as Starlink for backhaul instead of using fiber in low-income settings? I didn't know which one of our panelists would like to take a stab at this, but I'm open to anyone who would like to. Bill.
I'd like to take two comments. The first off is those LEO constellations aren't ready to do that yet. So the value of a model like this is to start allowing people to talk about the different models and the capabilities. Certainly the potential for a re-architecting very much mobile networks, how you build out by using the LEOs to do backhaul, mobile backhaul. That's already a big market, not just using LEOs, but using the high throughput satellites. But it could be a much, much bigger opportunity with the LEOs if they perform like Starlink and SpaceX hope they will. But that's very much a question. And there's a whole lot of other really cool stuff that the satellites are talking about doing, you know, mesh networks across the satellites and all that sort of stuff. And Julius should probably chime in on that too. But the other point I wanted to make was about the meta questions related to what Ed was saying, and also some of the stuff Tania was saying, which is that if you look at the model, the modular nature of it means that as we get better models, like for interference modeling of the Wi-Fi, or better data sets coming up from some of these markets where the World Bank's working, those can be added in or blended or be used to improve this, because the structure with the open source code means you don't have to rebuild the whole model when you get better abilities to deal with things at a different level. And that's really, really important going forward, because as different policy segments get better and build their own little models, figuring out how to talk across these and understand, you know, did the energy guys, when they analyze the costs of X, is their analysis usable in our framework? These kinds of models and the interoperability between them is going to be really important for that.
Fantastic. Thank you, Bill. We actually had a question from Jim for you. So if I can go back to Jim, I think he has one that he would like to ask.
Yeah, sure. Thanks, Ed, and apologies everyone for losing you there. I've gone from fiber to near but not quite at my premises onto 4G now, and it seems to be working a bit better. Actually, I wanted first to follow up on something that Bill hinted at there, which is around the capacity to assimilate new data sources to improve these models. And I'd be really interested from both Ed and possibly Julius in terms of what you foresee as being the most interesting data sources coming up, which will improve your modeling in the future.
Well, I mean, one of the first things is a big component of 5G and spectrum use, and a lot of the edge pushing research now is shifting away from a complete focus on communications based use of wireless. Wireless has and will continue to have a huge role in sensing, and there's all kinds of sensing technologies that are available, not just radio astronomy and space-based imaging stuff. We've seen some of that used by Ed, but also a lot of other stuff. And a lot of the Internet of Things is about much more situational awareness. Is that situational awareness becomes online, and as we start to solve some of the policy problems that have blocked machine learning algorithms for having access to large data sets, which raise a whole bunch of privacy and security issues that, you know, these models and all this sort of stuff is going to have to deal with. But putting those aside for a minute, that all of those data sets are going to provide capabilities, and there are open questions there, like if I have a really advanced sensing infrastructure in location X and then somewhere else in the country I have a less of one, but I've written regulations that in some sense are federal, how do I integrate those insights and analysis? I mean, there are open questions there at every level, from the theoretical statistical level down to the very practical and prosaic level of, you know, how do I design, for example, a competition program for universal service subsidies if I go to something like reverse auctions, and different parts of the country may be better able to make, put together a claim or an argument for that. We certainly saw that in the US after 2008. Massachusetts and California got disproportionate shares of the US federal funding because we had started figuring out how to go for that funding sooner than other places, and we had better modeling and data in place to make our cases.
Could we bring Tania in also at this point? Because Jim, you picked up that issue about, well, which global data sets do we need? And World Bank is working on some of these, and World Bank also has the kind of scope to be able to do this stuff. Tania, you mentioned before that you were working on trying to produce an open source spectrum database potentially for as much of Africa as you could do. This seems like a huge hole in our in our data input for the model at the moment. You know, we have to go to each country and try and estimate what spectrum portfolio there is. Are you able to talk about whether that's had any progress and whether you're working on any other potential open source data sets?
Yes, actually, in the case of a spectrum, actually, GSMA has already started collecting this information for the spectrum that is available specifically to mobile operators. So we are complementing, merging that source of information with others and specific inquiries to the countries to understand better the spectrum that has been assigned in different countries. So that's one area. The other one that is still important, at least in developing economies, is on taxation and also the fees and how much is paid for a spectrum as well, and regulatory fees. So we're working on a database about that as well that can help us with the policy options. But also at the World Bank, we work also with colleagues that are working in transportation and energy as well. So there is also this other database on other infrastructure that I think it's important at some point also to consider kind of the overlap, how the synergies between these different types of infrastructure. And I think that would be also an important next step. In the case, I mean, of energy is to use also the backbones or the fiber, but also understand the availability of electricity, that also has an effect, you know, on the last mile.
Fantastic, thank you. And actually, maybe we could go to Julius next then, because we did have a question which I think came from Calvin, which was talking about the coverage map, which I showed, which is your coverage map. So could you talk about how the coverage map was developed, and then also could you talk about how we, you know, whether we can use that data for infrastructure availability? I mean, I know you guys are already producing these maps and putting them out open source, but it seems like you've got, you know, probably the best coverage out of anyone else.
Yeah, the map that was shown is how the world says hello to Facebook. And that map was created in around 2018 or 2019, I believe, so it's a little bit outdated. About use of that data, unfortunately, I'm not personally familiar with it, so I have to defer to my other colleagues. I know a lot of the data has been open source, but I don't know if this specific one has been open source.
Okay, because I think at the moment we are, you know, working with estimated tower counts at the national level and basically doing disaggregations to try and work out how many towers there are in some sort of spatially disaggregated way. And that's fine when you aggregate it, it still sums up, but it's nice to have other data sets which help us understand where infrastructure is in different places. That really helps with kind of calibrating our models.
That's right, yeah.
Great. So I think we're almost out of questions now, so I'm happy to take any more that some of you may have. Jim, am I okay to pass back to you in case you have any further ones?
Yeah, sure. And I do actually have another question for Bill. You referred in passing to 2008 and rapid steps which were taken in Massachusetts then. And we're in a similar situation now. I was in a meeting with someone in the UK government right now talking about speeding up of infrastructure projects and ways in which government can create stimulus to help to get us out of recession. So what would be your advice if governments are really looking to accelerate 5G full fiber rollout? What are the steps they should take to speed things up over the next couple of years?
Well, first off, in response to COVID, there's a ton of people that are pointing to the fact that education, remote education, and the ability to work remotely has been incredibly important. And this view that, for example, networks that were being built in developed countries, they're mostly carrying entertainment, and they're mostly, mostly capacity was put in for asymmetric traffic. And then we see, oh, there's this huge increase in people doing video conferencing. You might say, well, that means is we absolutely have to build fiber to every household and make capacity be symmetric. And I think things like Ed's model and things like that show that, you know, there is a real need there and there are issues there, but you're overstating it. Actually the growth, for example, in video conferencing traffic was the single largest increase, and it was huge, but it's still not the majority of the traffic. And the networks in the US, for example, and in most of Europe, were largely able to scale. So there were some localized issues. Now, the question about what do you need for 5G, that's a little bit different. And it sort of changes. For example, if you're gonna have a debate about what kind of broadband you need, people that shifted because mobile broadband was really good for them and basically has gotten fast enough in the US. So a lot of people say, I don't need a fixed broadband connection. If you're in a household, everybody has smartphones, that's not really a good way for them to study. And if people are not leaving their homes, then there's sort of more of a demand for fixed broadband. So really, I would say one of the things that's come up in all of this is we need to throw a lot of money into the economy for infrastructure. Most of that is not going to be about building telecom infrastructure, although people are putting in the US and some of the bills that have been put forward, they're talking about upwards of $1 billion of new funding for broadband in the US, which I would say strikes me as a crazy number. But I mean, you know, I don't think you need that much money. I think it's mostly private investment. It's a refocusing on those programs. But to think through those arguments, you need to be clear. A big problem will be if you think it's private investment, and a lot of the solutions of the problems are, for example, improving the ability to get access to computer terminals or things like that. Those are much more localized, and there your problems are, how do you build out the small cells? How do you deal with the zoning? How do you get around local municipal deployments so that if a municipality wanted to do a fast deployment of, you know, for 5,000 people in a particular thing, can I bring up wireless really fast? To do that, to get the permitting, all that sort of stuff, and to give the people the models to do that, that's a really hard problem. So I think there's a lot of stuff from a regulatory perspective of clearing out problems to building out the investment is important, but also giving people ability to more realistically consider what the goals ought to be. So like in the US, there's a bifurcation between people saying, oh, you don't need that much better broadband, and other people saying that every household should have a gigabit. And you know, I personally am like, well, I'm not sure, you know, in the US right now, if you have 50 megabits to your house, then you probably are fine for doing anything that's really important right now in terms of like remote learning and stuff like that. And the issue of whether you can do that or not is more likely to be do you have the applications? Do other people have the investment? Is it like, can your teachers get the right kind of connectivity they need to local cloud resources or something like that? So it's a much more complicated problem.
That's great. Thanks very much indeed, Bill, for that. Any final remarks which any of our panelists might like to make before we close off? Tania, on that, it's interesting that Bill brought up those questions of how we're educating in COVID, and education is something which is of great interest to the bank.
Yes, exactly. The governments are also increasing their online programs. I think the first is like just using broadcast. I think all the different content from the past has been revived and used that for the first response. But now they are also more interested in actually increasing connectivity. And also actually the access device is one of the main problems. There, I mean, how to access a smartphone or a laptop. So there are also other countries there. I mean, especially right now, we are working with Turkey in a specific program on education that has been very successful in this phase. But there are other projects in other countries as well.
That's great. Thanks very much indeed, everyone. We've had a very wide-ranging discussion, which has gone from some quite technical issues to things much more related to the demand side, the regulation and the role of government of digital infrastructure. Thank you especially to Edward Oughton for your presentation and for all of your incredible work in the ITRC and subsequently. And to our panelists, Julia Kusuma from Facebook Connectivity, Bill Lehr from MIT, and Tania Begazzo from the World Bank. Great contributions, great discussion. This brings us, as I say, to the end of the main parts of the ITRC webinar series. So I hope everyone has found it interesting and worthwhile. We've covered a great deal of ground, and it's been a great pleasure to end here on digital infrastructure. We will be in touch to let you know when this webinar is online on YouTube, and we will be in touch with other events, including the event in the new year, when we'll be able to take you for a deeper dive and more of a tour through NISMOD on Daphne. But for now, thanks again for joining us, and thank you to all of your speakers, and have a very pleasant evening, afternoon, or morning, wherever you are. Bye-bye.
Thank you.
Bye.
Pleasure.
Everybody.
Pleasure.